What excited me the most about coming to work at NASA was that I was able to get my foot in the door at a place where I dreamed about working since I was a little kid. I used to play with Legos and build space shuttles. And so just the opportunity to work at a place like that really inspired me. I'm Brendan Short, and I'm a computer engineering master's student at the University of California, Santa Cruz, and my research interests are hybrid dynamics, control theory, and adaptable programming. What appealed to me about the internship here at NASA was that I would be able to work on UAS, which is Unmanned Aerial Systems, research, which is highly interesting to me, and also get programming experience that I need to continue to do the work that I do in my lab. So the challenges that are faced when integrating manned and unmanned aerial vehicles is that not all vehicles are equipped with the same technology, which makes figuring out their exact position difficult. And so what we were trying to determine is what is required for the UAS to actually be able to find any other aircraft. In situations where an aircraft does not have a transponder or something that allows its location to be identified by GPS, the second system that comes into play is redundant radar, with radar on board of the UAS and also ground radar. Using the data from both of those systems, we are able to actually fairly accurately pinpoint where the aircraft is in space, and by relaying that information back to the UAS, it is able to actually get a good position on the other aircraft. The research I'm doing here is building tools for data analysis, and one of the challenges I've run into in building these tools is that these tools rely on a lot of software systems that are written by other people and are maintained by other people. So if a change happens in that tool, it may break your tool, and in doing so, you need to go through every individual piece and figure out exactly where the problem is. So what I've been trying to do is create tools that detect these changes and account for them automatically so that the tool never breaks in the first place and nobody has to spend the time going through the entire chain and correcting the mistakes each time. And the other advantage of that is if, for whatever reason, somebody reverts to an old format, the tool will then recognize that and automatically compensate. My research here relates to what I'm doing at school because I am getting experience building data analysis systems and data visualization systems, and the lab that I work in at school, we run a lot of experiments with vehicles interacting with each other in a certain simulation or even in real scenarios. And so building these tools and learning how to build the tools that best display the data in a way that lets you really find out what's going on is very, very helpful in situations that I work with in my lab. If another student were considering applying to the SCI internship program, I would tell them that this is the best job that I've ever had. Not only has it been fun, I've been treated really well here, but I've learned almost more here than I have even at school because all of the stuff that I'm doing here is practical and related to real life things. Not only makes them exciting, but really makes you motivated to work on them.